Let us start. Okay. Today's class. Is it started?
Yes, sir.
So today we will discuss the next topic, that is skills, engineering skills. So the next topic is engineering skills. So what is the meaning of this? Let us try to understand. So as usual, that means we have the habit of attaching this term engineering with everything, right? So means mechanics, engineering mechanics, physics, engineering physics, chemistry, engineering chemistry. So everything is engineering, right? So that's how scale. So engineering skills, right? Next is what is the meaning of scales? Scale means basically you see that there is a term scalar, right? Scalar, scalar is a term you know. So what is the effect of scalar or scalar quantity? Scalar. What is the meaning actually? What is the meaning of that scalar? Only has magnitude, right? So that means if I multiply a scalar quantity with something, what it actually does? Means when you multiply something with a scalar, what it actually happens? For example, you have a vector. For example, you have a vector. You have a vector f. Let's say vector is like this. Vector is like this. Say. So this is the vector. This is the vector f. Now there is a scalar. Say a. If I multiply a with f, we get what? We get another vector, right? When we multiply a vector with a scalar, we get another vector. What is the effect? Say for example, this is say r. This is a vector. What is the effect? If a is more than 1, then it enlarges. If a is less than 1, then it reduces. Clear or not? That means this is f, and if a is say 2, for example, if for example, if a is equal to 2, what happens? What is r? R is like double of the length of f, isn't it? So this is f and double of that. So this is r, right? This is r. Clear? So it enlarges if a is more than 1. If a is less than 1, say for example half. A is equal to half. So what happens to r? It reduces. So that r is like this. this is R. That means if A is half, then R is this. If A is 2, then R is this. And if A is 1, then R is this. R is equal to F. Clear? So, that is the scalar. That is the scalar. The action is that either it reduces or enlarges. Right? So, accordingly, in our drawing, some components, right? What I need to draw on the drawing sheet. Drawing sheet, you have a particular size, right? You have a particular size. For example, A1 drawing sheet or A2 drawing sheet or say A0 drawing sheet. So you have a particular fixed size, but this is not necessarily all the things that you are basically going to draw may not fit in the drawing sheet. Say for example, you want to draw the design of a car, right? You want to draw the car, for example. Maybe you can draw in computer, but definitely you need to print it. Right? So you cannot print on a size the same as that of a car. Right? The car may be say 5 meter long. So you cannot draw it on a drawing sheet of that size. Clear? So what you need, therefore, you need to reduce it so that it will fit within the boundary. Clear? One thing. There may be some very miniaturized things. So if you want to draw that, say components of say mobile, right? Or say components of, for example, you need to do the components of computer, right? Motherboard. Or for example, watch. The watch, you have very tiny components, right? So if I want to draw it on the drawing sheet, the pencil size will be very gross to that compared to that, isn't it? Say for example, I want to draw the pinions or the gears of the watch. The size of pencil will be more gross to compared to the pinion. So I cannot draw it effectively. Isn't it? It will be erroneous, right? So in that case, what I have to do? So what we do actually, when you see, take a photo, then enlarge, so that I can see, isn't it? So when we draw, when I actually want to see, I take a photo, then enlarge the photo. Clear? Why we do that? So that we can read it properly. Do you understand that? So that is what is that called? Enlarging or enlargement, right? So one is reducing scale. So that means how much we are increasing or how much we are reducing compared to these two. That means it is the true size, actual size. It is the actual size. It is the actual size. Right? Now it is enlarged size. So what we have done? We have multiplied with 2. So that is called enlarging scale. Enlarging scale. So what is the ratio? 2 is to 1. What is the meaning? What is 2 and what is 1? That means it is the final size of the drawing is 2 and 1 is the original size. So that means there are two parts. One is the drawing size, another is the actual size of the object. So there are two components, two parameters. One is, both are dimensions. One is the dimension of the drawing, another is the dimension of the actual object. Say for example, when you have a car, actual car is more and the drawing size is less. So in that case, what will be the scale? Half. That is 1:2. When you want to enlarge, then actual size is less and the drawing size is more. So 2:1. So therefore we define a scale, and in that case we will actually write the scale in terms of a particular name, that is called RF. RF. What is that? Representative factor. Representative factor, or you can say representative fraction also, because factor means basically you can definitely have smaller than one, larger than one, both. So representative factor or representative fraction. Okay. So how can I define that? This is defined as actual size or length of the object concerned. Length of drawing by actual length of the object. Length of drawing by actual length of the object. So here, for this, what is that? Enlargement. What is this? Reduction. Right? Reduction. So therefore, there will be two scales. One is called the reduction scale. Reduction scale. So in that case, or reducing scale, right? Or reducing scale. That means where RF is basically reducing scale, means RF is less than 1, right? You are reducing. So from the actual drawing you are reducing. So that is reducing scale. And one is enlarging scale. Where RF is more than 1. Okay. And when RF is equal to 1, we call it full scale. So when RF is equal to 1, you have full scale. Or full size scale. Okay. So the idea of scale is clear. That means it is not always possible to draw the object with actual dimension. So either we need to increase it or need to reduce it, depending on the size. If it is very small, I have to zoom it in, enlargement. So I will use the drawing size more than the actual size. So in that case, RF is more than 1. So when the drawing is very large, I need not draw it with actual size. Right? I can reduce it, and in that case, means even in reducing that dimension, we will not lose any accuracy, at least in the drawing. So we will reduce it comfortably so that we can draw and print in the particular size. Clear? And full scale means when we are drawing with exact dimension. as it is. Clear? So in the first sheet you had a scale, right? Scale. So 1:1 we have written, right? So that means we are drawing with the exact dimension that is given. So that is full scale. So first of all, is it clear? So idea of scales. Now in the reducing scale, we will be giving you a particular range of the values. That means scales cannot be used randomly. Okay, scales cannot be used randomly. There is a recommended values of scales. Like say you have 1:2, then 1:5, 1:10, like that. So it is say 1:2, then 1:5, then 1:10, like that. Again, say for example 1:20, 1:50, 1:100. So like that it will grow simply. Okay, so 1:200, 1:2000. So this way you can compute. That way you can compute. Right? Only these are recommended scales, but definitely sometimes some other values can be used, but these are basically special cases, right? But generally we will be recommended to use these scales, right? Similarly, in enlarging scales you have opposite, so it will be 2:1. So 2:1, then 5:1, and 10:1. Clear? Then 20:1 and 50:1. And this is full scale. What is that? 1:1. Clear? Okay. Next thing is so idea is clear, I guess. Okay. So you commonly use some scales, right? Like say you have a ruler. What is that? Can you give one? So have you seen any scales? Earlier, prior to this class, have you seen any scales? Like say for example, some drawing which is not in its exact say length, with its exact length. Have you seen? I know you have seen, but you are not able to remember. Workshop.
Emergency escape of building. Emergency escape path of building.
Building. building of a drawing you have seen, and here there is a different length. Definitely the building cannot be drawn on the exact size of the building, right? Then the building will not be completed. The drawing cannot be completed itself, right? Right? If you have to draw the building on the sheet, the size of the building, then the building, whatever the building, forget about the building. The drawing of the building cannot be completed, isn't it? So the thing is that other scales that you have seen, any other scales? Huh? Screw gauge. Screw gauge is an instrument, isn't it? So I want to ask you that what drawing you have seen already that has a scale. Have you seen maps, political maps? Right? This is representing India. This is representing India, not exactly India. Right? The map of India, political map of India, for example. You see, it is representing. That drawing is representing you. Say, for example, if I take a photograph of you in the mobile, the size of your, say, full body will be fitted on the drawing. So, whatever I see is not the exact size. Right? That is representing you. Right? If I take a photograph of an elephant and an ant, both will fit in my drawing, but they are simply representing the particular animal. Is it clear? That means starting from an ant or ewe or an elephant, everything is fitted within the screen, right? But they are basically representing that particular animal. Clear? Okay. So in a map you see, in a map you have seen that, say, 1 centimeter is representing, say, 100 kilometer, or say, for example, 1 centimeter is representing 500 kilometer. That means what? What is RF? If 1 centimeter represents 500 kilometers, what is RF? Can you tell? What is RF? What is that? Please try to understand. Try to answer. What is RF in that case? What is RF? If 1 centimeter is representing 500 kilometer, so RF, what is that? Length of the drawing. What is 1 centimeter, and actual size 500 kilometers. So I have to convert into the same unit so that it remains as ratio only. So 1 centimeter divided by 500 kilometers multiplied by 1 kilometer means how much centimeter? 10 to the power 3 meter, then 10 to the power 2 centimeter. So kilometer, hectometer, like that you can get it. So 1 kilometer is equal to 10 to the power 3 meter, and then 1 meter is equal to 10 to the power 2 centimeters. So what is it therefore? What is that? 1 by how much? 5 into 10 to the power 7, right? So this is the RF. This is the RF. So you can calculate, if the value is given like this in watts, you can calculate what is RF. Right. Next is why. One thing is, this is a scale. What is that scale?
Centimeters.
This is a scale. This is what type of scale? Full size scale. That means if I measure something from this, it will be exact length. Right? So that means when you draw something, say for example, I ask you to draw a circle of say diameter 10 centimeter. So what you will draw? Like this. 10 centimeter. So how you measure 10 centimeter radius? 10 centimeter radius. So this is the circle of radius 10 centimeter. Then you will measure from this scale and draw this by the compass. Okay. Now, if I ask you, please follow. Lecture din hai. Come here. We all will listen to you. I will also enjoy that. Come here. So do you think that that is your freedom to talk there, right? It is your freedom that you will talk there during the class. Assume some responsibility, okay? It is not the freedom of a student to just attend the class and keep on talking and disturbing another. You are actually kind of destroying your own future and at the same time another's. You do not understand what you are doing. Now once you will go complete the semester, then I do not know whether you will understand after 4 years maybe. But in my class, you are not allowed to disturb. Okay, if you want to disturb, then both of you go outside the class. There are plenty of trees. Okay, decorated. You can enjoy there. Decorated, isn't it? Colored, well furnished. So you can take tree, birds, many things are there. So you can. Okay. So next time we will not disturb you. Okay, clear? I will not just talk to you. I will remove you from the class. Next time. Okay? So now the thing is that I have drawn it successfully, quickly. That means if I ask you to draw one circle of say radius 10 centimeter, then you will measure 10 centimeter from here and simply draw. Right? If I ask you to draw, say for example, a scale or a circle of radius 11 centimeter, you will measure and draw. So whatever I ask, you can immediately draw. Right? Now, in a reducing scale or in an enlarging scale, how will you draw that? Say for example, if I ask you to draw a circle of radius 10 centimeter in a reduced scale of 1:2, what you will do?
You will draw the circle of radius
5
centimeter.
5. So radius will be 5. Again, if I ask you to draw a circle of radius 11 centimeter, you will use 5.5. Right? Now, here, say for example, I can easily draw, say for example, 5.5. Can you measure in a millimeter scale? Simple millimeter.
Yes.
11, right? 11 is the radius. So in a millimeter scale, 0.5 is there. Is it available? If it is not available, then how can you?
You will take the middle of this. You will take the middle of this.
No. You don't have the idea. Measurement depends on whatever is the that is called the least count, right? You cannot go beyond that. You are allowed to use a millimeter scale only up to millimeter. You cannot use 0.5, from the same scale, you cannot do 0.5. Right? By eye estimation, you cannot trust eye. If you are trusting the scale, at the same time you cannot guess, because accuracy of your drawing cannot depend on your eye. It should be dependent on the scale or the instrument, right? So you cannot use if it is not given. So if it is 1 millimeter, then you cannot go beyond 1 millimeter. 0.5 is not allowed. Clear or not? Okay. So I think it was. Hello. Hello. Working? Okay.
The sound stopped it earlier. So, therefore, the idea is that why I need a scale? Why I need a scale? That means for 1:1 scale, this is they are available. But if I need enlarging scale or reducing scale, so I need another scale from where I will measure. All the time I will not calculate. Say for example 10 is given, I will divide by 2, then I will calculate. Or 11 is given, I will divide by 2 and then I will measure. That is not possible. Always I will not calculate. So to replace that calculation, I will construct a scale. Is it clear? That means here, since it is 1:1, whatever given, I know that that is the drawing size. Whatever given to draw, that is the drawing size. I know immediately I am drawing. Okay, yeah. So for reducing scale or enlarging scale, that is not the case. What happened? Okay, so in that case, the reducing scale, what I need therefore, do I use a calculator for that and use the same scale? Will it be convenient? I have thousands of measurements in the drawing. So will I use a calculator and do it? It is not possible. So I will construct a scale which is basically that particular scale. So either 1:2 or 1:5 or 1:10, whatever scale I will use in the drawing. That scale I will construct first, and then from that, if I am given the 10 millimeter or 11 millimeter, I will measure 11 from that, because that is representing 11 millimeter. Right? What I will do, say for example, this is of say 30 centimeter, right? So if it is 1:2, then what will be the length of the scale? 15. So there will be a term called length of scale. LOS. So what is that? Length of scale. That means length of scale. That means what is the use of the length of the scale? With this, how much maximum length that you can measure?
30 centimeters.
30 centimeters. So there is another concept called maximum length to be measured. Maximum length to be measured. Clear? So length of scale and maximum length to be measured. For this case, both are same. Both are same because this is full size scale 1:1. Both are same. But when you have these things, they will be differing. Is it clear? So therefore, their ratio and this ratio, they said that means this RF can be written as, which is what, can you tell? Which corresponds to what?
Sir, length of scale is to maximum length of.
Length of the scale means basically drawing. So it is connected or associated or corresponding to this, because this is the scale that we will use. So that is a kind of drawing, right? That is a kind of drawing. And maximum length to be measured, this is a kind of actual length. Clear? Is it clear? Is it clear till now? So why we need something and then how to use it? Is it clear? Next is, therefore I can write the same thing, representative factor, as length of the scale. So here length of scale then maximum length will be measured. Clear or not? Is it clear? Is the concept clear? Everyone, is it clear? Because you will use these things in the problem. So RF is equal to this. Clear? Okay. Therefore, once I know that in the drawing I will use a particular scale, say 1:10 or 1:20 or 1:2, whatever, then I will make a scale corresponding to that. That means if it is 1:2, then I will reduce it. I will reduce it, and that means what will I do is, if I am asked to draw a circle of radius 10 millimeter, then from this I will measure 10. I will not calculate anything, because this is now representing 10. Whatever 10. So half of that is representing 30, and therefore accordingly 10 I can measure, because I have just reduced it. So what you will do basically, you will take a photo in full scale and then zoom it to half, right? And then from that you will measure 10 only, because that is representing 10. Clear? You will not do any calculation. That is actually, that making of the scale is making your job convenient, more convenient. Is it clear? That means you have not to calculate anything, because you have done the scale. You have reduced the scale, you have produced the scale, and then what you do? Simply measure from that and do that, calculate, do that drawing. You don't have to calculate. The calculation power is inbuilt in this. It is inbuilt in this scale, right? So there will be basically 3 scales that we will discuss in our course. First one is, so these are the RF values. Depending on RF values, you have reducing scale, enlarging scale, and full size scale. Okay. Now there will be, so we will use this frequently. Remember,